one final thing I want to do here in this section on integration by parts, and that is to derive a reduction formula. So there's many reduction formulas. You can look in the book for more reduction formulas, but here's an example of one. So what's going on here? On the left, we see that we have an integral of sine of x raised to the nth power, and so that would be a difficult integral for us to do. So, and we're thinking as some positive integer, this would be asking you to evaluate the integral of sine of x raised to, let's say, the 11th power or something like that. And so instead of giving us a straightforward answer, what this formula does is that it reduces the integral to a simpler one. Let's see what's going on over here. So we would have minus 1 over n times sine of x raised to the n minus first power times cosine x. So that's a pretty simple term. Plus n minus 1 over n times the integral of sine of x raised to the n minus 2 power. And so what happens is that we are reducing the power of the integral, the power of sine that we have to integrate in our integral. So if over here this is n is equal to 11, this would be n is equal to 9. And this formula would allow us to, we could use it recursively. Then we could say, okay, sine of x, the integral of sine of x raised to the 9th power, well, then we could get that ... in terms of sine of x raised to the 7th power, and keep reducing all the way down using recursion until we get an integral that we can quickly evaluate. Before I go on with this, I do want to comment a little bit on the notation here. So when I write sine of x, sine to the n of x here, what I really mean is sine of x raised to the nth power. So I copied this first line, that better matches what's in the textbook, but I think it would be a little bit easier for us if I write this style of coefficients. This style of exponents here. So sine of x raised to the n minus 2 power. Okay, so let's get into this. We're in the integration by parts section, so we want to apply integration by parts over here to the integral of sine of x raised to the nth power. Now, this looks weird. There's no obvious choices for us to make here. However, there's a little trick that we can do. So let's just remember one last time, see this page. Choose dv so that v is easy to calculate. We want to choose something that's easier for us to integrate here. So we're going to have a little trick here. We're going to rewrite sine of x raised to the nth power as sine of x raised to n minus 1 power times sine of x dx. So we're doing a little bit of unsimplifying here. We've got something raised to the nth power. We're splitting it off as something raised to n minus 1 power times that something. We're rewriting x to the 8th, sine of x to the 8th, as sine of x to the 7th times sine x. And so now what we can do is that we can say, hey, maybe this can be our choice for dv, and this can be our choice for u. So if we make these choices here, u is equal to sine x raised to n minus 1 power. We can take the derivative of that using the chain rule. So that n minus 1 comes down, sine of x raised to n minus 2, and chain rule, take the derivative of what's on the inside there, cosine x. And dv now is going to be sine x dx, and we can easily integrate this. So integrating sine of x gives us minus cosine x. Okay, so let's write out what formula we get. Let's write out what formula we get from integration by parts. So recopying, this is what we are aiming for here. It is u times v, so that's minus sine x raised to the n minus 1 power times cosine x minus the integral of v du. And I have forgotten a little dx there. Can't forget that du needs to be written in terms of dx. Sorry for the mistake. Okay, so v was minus cosine x, du was n minus 1 times sine of x raised to the n minus 2 times cosine x dx. Okay, so let's manipulate this a little bit. So this first term, we're just going to leave that chillin' out in front. Now for the second integral, minus and minus, so those would combine together to be a plus. And this n minus 1 factor I can take outside the integral. And we've got two factors of cosine x, so I'm going to combine them as a cosine squared x times sine of x raised to n minus 2 power dx. Okay, so far so good. Now we are left with having to deal with this integral over here. Now, there's a kind of clever trick for us to use, and this is an important trick to know. We're going to be using this trick all the time when we hit the next section. And so the trick here is saying, well, if sine squared x plus cosine squared x is equal to 1, we can rearrange this to get cosine squared x is equal to 1 minus sine squared x. And so at this point then, we're going to replace the cosine squared with 1 minus sine squared, so we won't have a cosine, we won't have any cosines inside our integral. So after making these changes, okay, I'm just going to copy down the stuff that isn't changing right now. Okay, so we replace cosine squared x with 1 minus sine squared x times sine x raised to n minus 2 power dx. Okay, so now, so far so good. The next thing for us to do is we're going to expand this out. And so 1 times the integral of 1 times this minus the integral of sine squared x times this. So we're going to break that up as two separate integrals. So when we do this, the integral of sine x to the n dx is minus, so this is the boring part, we're just recopying things that we know, plus n minus 1 times, first we're going to do the integral of 1 times sine of x raised to n minus 2 power. And then we're going to do n minus 1 times minus sine squared x times sine of x raised to n minus 2. Sine squared x times sine x raised to n minus 2 is just going to be sine x raised to the nth power. So that would be, so there's a minus sign, n minus 1, sine of x raised to the nth power dx. Okay, so here's our current place. Now let's see if we can spot what we want to do here. So remember, usually, we want to say, well, one of these integrals should be easy for us to do, but we could use the trick that we did earlier when it looked like we were going in loops. Note that this integral here is the same as this integral over here. These are exactly the same. So if I call this, let me call this I like we were doing before. I'll also call this integral I. And now it just becomes a game of solving for I. So we have I over here. We add n minus 1 times I. So that would give us 1 plus n minus 1 is n times I is equal to minus sine x raised to n minus first power times cosine x plus n minus 1 times this integral here. And then, of course, our final step to do to finish this off is going to be divide by n. And so I, which I'm just going to put back here, which is the thing we're going for, is minus 1 over divide by n, sine x raised to the n minus 1 power cosine x, plus n minus 1 over n times the integral of sine x raised to n minus 2 power dx. And if you take a look and we bring back the original page of notes here, this is exactly what we were going for. So hooray, hooray, we have finished off finding this reduction formula.